In my business, I move water tanks around the world, and because they're so bulky, it costs me a fortune. So I wanted to find a way to move them in parts and assemble them at their destination. My invention is a strong and flexible joining system for almost any material. The two interlocking edges mesh together like the teeth on a zipper. The locking piece, or key, is placed between the hooks and locked to wedge the parts firmly together. It can be easily unlocked and taken apart. The parts join together quickly and the seal holds tight even under pressure. Now when we need to move a water tank, we can transport it at a much smaller size and a quarter of the cost. The parts stack inside each other and when they get to site can be quickly joined together to make a strong water tank. Forget the nuts and bolts. My invention is the future in joining parts.
Please welcome from Mullaney, just north of Brisbane, Dean Cameron. Hey, Dean.
Thank you.
And how's Biolytix going?
Really well.
Yeah?
Yeah. We've just got a 1,000-lot subdivision down in Point Boston and, yeah, a lot of opportunities.
Do you just want to show us how you how it works? For example, with this. What's this called again?
Well, this is actually a pressure vessel.
Yeah.
And the way they would normally have been joined is by screws and bolts down.
All those bolts down the bottom. And that'd take quite a while, wouldn't it?
Even with the drill, you're looking at about 30 seconds apiece.
OK, so that's a good many minutes.
Gives you a bit of an idea of how long it'll take. What happens here is I can actually slip this in between the two clips.
Yes.
And just roll that round.
Yep.
So actually the whole thing works in.
Yep.
And then move it sideways and simply lock it up. And the whole process only takes seconds.
Well, this many seconds. And that now is airtight, watertight. Is it as strong?
It becomes a pressure vessel, yeah, it's just as strong.
And then some of the applications are really interesting, like with things like this that might be on cars or on planes, usually you have to create pressure points, don't you, where the screws or whatever go.
That's correct.
But with these, you can sort of spread it over the whole surface.
Yeah, this is a method of joining even quite complex curved structures that gives it a lot of structural integrity and doesn't actually, you know, it's so quick.
Yep.
But it gives you a nice strong joint.
And again, another corner like that, turn it round, and that's as strong as any corner, you reckon?
Yeah, and you can, you can pull it apart.
Just like that, reuse it.
Reuse it. Simple as that.
Come across to the panel. It's quite amazing. In terms of, I mean, we talked about it being faster, but is it actually literally going to be cheaper than its competitors?
Well, yes, it uses less material. If you look at the flange, you've actually got to have enough width to get your bolt on, so that makes more material. But also, it actually starts to open the flange up, so pressure on it actually puts a bending stress on against those bolts. What this does is it converts the pressure into a tensile strength. Yeah. Which is like what happens with clams, in fact. So
that's where you got your inspiration.
One of the you can't help yourself, can you?
You won't be satisfied until you've stolen every idea from nature and made it your own.
So you made it look very simple in the demonstration. But is it easy to make sure that is a good seal? And do you have different seals for different liquids?
Yeah, you would. And you'd have different joints for different purposes.
And if you get a failure, I mean, do you have to pull the whole thing bits to get to fix a failure, or can you actually fix it in situ if you've got a water leak, for example?
No. It's the same as a bolt. In a bolted flange, you'd have to, if your seal failed, you'd actually have to undo all of those bolts and take it apart. You can just pull it apart in seconds, put a new one in, put it back together.
Because I was going to ask about fatigue, because, you know, with the interlocking parts all around the edge, how are you going to cope with fatigue there on the joint? How does it perform compared to a flange with bolts where you've got the spots for fatigue?
What you're doing is you're actually transferring what would normally be a flexural load and a shear load into a tensile load. By converting it into a tensile load, you're actually able to take much higher pressures.
With your pressure container, I noticed that when you pull it apart, there is a rubber or some sort of a neoprene,
like
perhaps, seal inside. And I'm just wondering whether or not if you didn't want to disassemble that down the track, whether you could just use like a squirting silicone or something to get that.
Yes, you could. Yeah, if you wanted a permanent
seal.
bond, then there's one other point too. Like in a vehicle or an aircraft where it's subject to a lot of vibration and constant stress, you can actually create a brace out of the key itself. Can be bonded, so you put the whole lot together with glue, or like a silicone adhesive, like you say, and then lock it up. And the whole thing then becomes both the brace and the key, and you can actually join another part to the key. So the key can have join lock keys on the edge of it, which end up joining it to another part, and you create a double shell.
You've done your thinking. Summing up.
Well, I mean, you've taken a piano hinge, really, chopped the top out of it and given it a whole new...
Pretty similar, actually.
Yeah, I think you'll surprise yourself with this, to be honest. I think it's absolutely fantastic.
Oh, I was going to say you've combined a door hinge and a zip.
Well, it is the same thing.
But it is absolutely mind-blowing because you see this, you see a water tank, but really the possibilities for this are almost limitless. It's the beginning of a new way of joining things. It's phenomenal.
I was thinking the Sydney Harbour Bridge. Well, could you zip it all up together?
I was thinking the Opera House, because why have boxy architecture when you can actually create beautiful shapes that are quick and cheap? And...
Hey, we've already built them.
Well, it's amazing. Good on you, Dean. I think you've done it again. Please thank Dean Cameron.
Thank you.
I put my vote for Joinlox.
Dean Cameron's the winner, right? Joinlox. Well done, Dean. Congratulations.
Thank you.
Well done. So, Dean's our winner. Well, it was a very...